Yes, please.
Okay, so dear participants, my name is Lunara Zakieva. I am the marketing manager of the School of Engineering and Digital Sciences. We are welcoming you on the webinar Industrial Digitalization Applications in the World-Class Aerospace Companies by Professor and the Head of Mechanical and Aerospace Engineering Department at Essam Shehab. So we can start.
Thank you. Thank you very much. Thank you very much, Leonara. Good afternoon, everyone. And it is a great pleasure to welcome you to my presentation about industrial digitalization in large aerospace companies. We'll focus on aerospace in our talk. My name is Essam Shehab. I'm a professor of digital manufacturing and the head of mechanical and aerospace engineering department at Nazarbayev University. So in this presentation, I will cover three main areas. So I will highlight, an overview of our department, mechanical and aerospace engineering, and also a digitalization project with large aerospace companies like Airbus and Rolls-Royce, Lufthansa as well. And what are the challenges of digital transformation? This is about myself. So I came from the UK, from Cranfield University, and I have very strong link with Airbus and Rolls-Royce. This is over the last like 13, 14 years. And in Airbus, for example, I have finished many group projects, many individual projects with the company. Over than more 100 students. They have done projects under my supervision, and also PhD student. And this is last from 2007 until this year. I have the same experience with Rolls-Royce. So this is a two major aerospace company in the UK and maybe also in the world as well. So this is Rolls-Royce like engine manufacturing. It's not Rolls-Royce car, they are different. So this is the Rolls-Royce engine manufacturing, and they have the same experience as well over the last 14 years with Rolls-Royce. So many of my students, they have done projects in the company, and also in terms of like, master students, PhD students. And now my students become like, top management in Rolls-Royce. So I have more than 30 students. They have joined the company after their project, and they, becoming like senior management in the company as well. In terms of our department, Mechanical and Aerospace Engineering Department at Nazarbayev University, so the department really having a very good international team. So they are coming from different countries, from UK, from France, Germany, and other countries as well. And this is showing the diversity. So once you have the diversity, you have excellent team to work with. This is to support our students and our collaboration with industry. And my colleagues, you can see them in this slide. As I mentioned, there are different expertise doing research as well as teaching to our students, collaborating with companies. So in our department, or in my department, Mechanical and Aerospace Engineering, we have like three programs. So the first program is the BEng in Mechanical Aerospace Engineering. And then we have also MSc, master program. This is 2 years MSc, and the BEng are 4 years. So the MSc also Mechanical Aerospace for 2 years. Also, we have PhD for 4 years in mechanical engineering. So this is the three main programs in the department. And of course, once our students are finishing, they have very good, careers in different companies. And there is a huge demand for on our students to be employed in companies. And I will show you some examples of this as well. So this is some of our companies we are working with. Like as I mentioned myself, I mainly with Airbus, Rolls-Royce, and Air Astana. This is like aerospace side. And of course, the colleagues in the department, they're working with other companies like BI Group, KPMG, Deloitte, and other companies as well, McKinsey. So we are doing real life projects. So some of our projects are real life from research as well as students engagement with the companies, which is giving the students a very good experience in real life companies. So this is an example of a project with Air Astana. So Air Astana, and today even I have another meeting with Air Astana for another project as well. So the company would like to have like a heavy maintenance workshop in North Sultan here. So they have workshop in Almaty, but they said, okay, we need to have another workshop like similar to Lufthansa like scale. So during the project for 4 months, I had like 4 students, master students. You can see their pictures here, and they have done this like a feasibility study of developing the heavy maintenance workshops to look at different like areas for maintenance of the aircraft. And so the students collecting the data, try to analyze the data, and then they visited S7 in Russia to look at their workshop as well. And then they come up with like proposal of the workshop for Air Astana in North Sultan to have this hub here in the city here. And even today, as I mentioned, this is the director of maintenance and his manager. And after we finish, immediately they offer the students jobs. And like 3 of the students said, no, we have already jobs already. And only 1 student, so Ayman, she took the offer and now she's working in Air Astana. Again, this is one of the benefits is to deliver to real life companies to have the knowledge. And then I hope we have some employment, as I mentioned in this example. So this is the background of the department and some of our activities. Now, of course, nowadays there's a lot of challenges for industry. So always the customer, they demand better capability from the product, better functionality. They need to have this product faster in terms of delivery to the customer, also the cost effective, on demand to specifications. And if you look at all of this, like picture here, you have like complex products. So the complexity is very high in this product. And even in our level as a like normal customer, if you look at your mobile phone or your washing machine at home or your vacuum cleaner or in your car, so you demand more functionality. You demand the product to become like cheaper and all of this. All of this will have a lot of like pressure on the companies to satisfy the customer and exceeding their needs. And of course, the companies, they are not like in one location. So most of the time, the companies are on different time zones. Like maybe they are here in Kazakhstan, or they are in France or China or like US. So there are different milestones. And when you look at the complexity of the product, you'll see the product is composed of many components. Like for example, you have seen the picture of A380 aircraft. So the A380, it has 6 million components. So imagine an aircraft has 6 million components, which is a picture even behind me as well. So all of this, like adding complexity to the supply chain, to the assembly, to deliver to the customer, to the maintenance. And like aerospace, for example, they are working in a highly regulated environment because there's a lot of certification to be having from authorities. That's why all of this adding complexity. And the aerospace companies, for example, they have huge legacy systems. So you have many systems inside the company, which adding to data retention. So how to keep the data for 100 years, because the aircraft life is about 60 years. And then the company has to keep the data for another 40 years after disposing the aircraft itself. So for any investigation in the future. So how can we keep the data for this 100 years is a big challenge for the companies. Of course, you can see this is revolutions in terms of industry. So the industry revolution started from in England, from industry one, the first revolution. This is about 1887, something like this. And this was based on steam power, water power, shafts, and so on. Then once we have electricity, so become more flexible in terms of production, in terms of like layout of the company or the factory. So we have the electric energy as the second revolution. Then this would talk about 100 years. Then the third revolution again took about nearly 100 years again. So we have the third revolution, which is about using computer in the factory, in the companies, using ITs and so on. Then it's coming now to the fourth industrial revolution, which took about 70 years to start realizing the fourth industrial revolution, which is based on cyber physical systems. So how can we have a digital system as well as having a physical system? How they are interacting together. How can we use this digitalization in the companies to produce smart manufacturing and smart product. So the industry 4.0, which is known now, or fourth industrial revolution, is about using like ICT to improve across the life cycle, from design, manufacturing, and through life services as well. So how can we optimize the design process, do the simulation, visualization, and also look at the connecting between the physical product and the manufacturing and supply chain, how this can become digital together. So it is about using all of this IT to have automation. As I mentioned today, for example, I had a meeting with Air Astana, and we are talking about automation in one area in the company. So how can this become more automated and try to use the IT skills, all the software, all the digitalization tools to help the companies moving forward to the fourth industrial revolution. And of course, under current circumstance, which is the COVID-19 coronavirus, so the companies now is rushing more to become more digital. So COVID-19 is a big challenge for the whole world, but in the same time, it is an opportunity. So we can take this opportunity to become more smart in terms of our working. And even now we have this webinar, which all of these technologies can help us to save our time and traveling in manufacturing process and others. So nowadays, if you look at the product life cycle starting from design, manufacturing, services, operational, all of this as a different stages in the product life cycle. But when you look at this product life cycle in our companies, especially larger companies, you can see separation or silos. So they are in silos. Like the designer designs their product over the wall to manufacturing engineer, then to the operation, and each team they have their own tools and so on. So they are not digitally connected. So the life cycle itself is not connected in terms of digital. So this is a big challenge for the companies. So what would be the ideal scenario? Is to have a digital thread. So digital thread means you are connecting the life cycle together. So if something happened in the initial stage of the concept phase, so all of other phases can see this change. And all of other phases can use this change as well to improve their operational. So it has to be digitally thread. And this is like, the integration across the life cycle. This really what we need in terms of digital transformation. So how to transform the company to become digitally connected from their product, from their service, from their operational, how they are connected together. So I will highlight a few projects which I have done with Airbus. So this is the first one I would like to show you. This is the A380 project. It's the wing of Airbus in UK. So the design team, they are based in Filton. And the manufacturing team, they are based in Bristol. And this between both of them, imagine you are in Almaty and Nur Sultan. It's so big difference between the two cities. So sometimes when they assemble the product in Wales, so they see some problem in assembly. And this is called concession. So concession means if I would like to assemble this component, I see some problem. So what I will do, I will ask the manufacturing engineer, will contact the design engineer and try to solve this problem. Some of this concession of these problems can take up to 6 months. To solve a problem in the aircraft in terms of assembly can take up to 6 months. So Airbus approached me to find a solution for this problem. So we have proposed to have digital mockup. So digital mockup to link the design team with the manufacturing team together. And so the manufacturing on the shop floor can see the design, and then they can annotate the design and said, okay, designers, be careful. There's a concession will happen here. So try to sort out this concession. So this is the aim to reduce the concession time to like a few weeks rather than 6 months. And this was the first project with Airbus A380. So the second project I would like to highlight as well, as I mentioned, there are many projects, but just I will highlight a few projects here. Was about A320. So I think all of you traveling with Air Astana or other airlines, and you have been in A320. So the Airbus A320 designed and the manufacturing, designed like 1970s. So during that time, with nearly everything manual drawings, if you remember manual drawings, 2D drawings, and then Airbus again approached us, can we transfer this 2D drawings and the manual drawings to 3D models, like using CATIA. So the team here and Airbus gave us this component to have the concept really. So the team here went through all these scanning companies, try to find solution, how can we transfer from a physical component to 3D CATIA model. And of course, they done all of the analysis and gives a proposal to Airbus. It's about digitalization of A320 design. This is another project with Rolls-Royce. You can. I'm talking about Rolls-Royce engine, by the way, not Rolls-Royce cars. They are two separate companies. So Rolls-Royce engine here. If you imagine this disk here, so in the beginning you have only one document, which is called the requirements document for this disk. So the requirements is the document said, okay, what is the disk and so on. Then this requirement will go through a number of stages to start realizing this disk. And all of these stages will create, other documentation, design, and so on. So by the end of the delivery of this disk to the engine, it will have about 400 documents. So producing one document to 400 documents. So all of these are not linked together. They are not integrated. So one of my contacts in Rolls-Royce, Phil Bamforth, he told me, okay, this is not connected. How can we learn from banking system? So banking systems are connected together in terms of documentation, in terms of workflow. how can we learn from them and then apply to manufacturing, because manufacturing also is a complex. So we agreed to start a PhD student for 3 years to look at the digital workflow, how to link this together, how to integrate all of the workflow across the life cycle of the components and then the product. So of course, the workflow here means you have a lot of processes, and each process has multiple people around. You have many functions. Sometimes you have different countries to finish a process, different time zones, different requirements, and all of this is what we need really to connect all of this together to have a digital workflow. So the workflow, as I show you this example, so this will be like, normally they are doing this manual. Manual means like, different systems, different Excel sheets and so on, different documentation, and they are not really connected. So the idea here is to have a workflow which is integrated and connected together. So if any changes in the initial phase, all the other phases can see these changes. Then this will reduce the time and deliver the component or subsystem or system easily to the final stage. So the second project or the third project now is about digital twin. This was Airbus. So digital twin means you have the physical aircraft in terms of design, manufacturing, the aircraft itself, and then you have the virtual side as well. So, and this has to be linked together. So is the virtual which replicate is the twin of the physical. And then you have a connection between both of them. So the Airbus asked, okay, can you have a digital twin for aircraft life cycle, the life cycle? Of course, we have a PhD students work in this area, but there's a big challenge in the beginning about data. Because when you talk about digital twin, you need to have data to build the digital twin. So now what we are doing, we're developing like data management to enable us to go for the next phase, developing the digital twin, which is like, it's a big challenge in a big organization with different, complexity levels from design, manufacturing, supply chain, as well as the aircraft itself. This is with Lufthansa project, which is very interesting project with Lufthansa. So the company, they are using, huge number of aircrafts flying everywhere, maybe in Astana or Nur Sultan here, which sometimes is -30, -40. Sometimes traveling the aircraft again to Dubai or something. So it's about 50 degrees. So different weather conditions, different flight profiles. And when the aircraft need maintenance, normally what they do, they have like a visual maintenance, for example, in terms of structure of the aircraft. And then they said, okay, this needs maintenance, do the maintenance, and then they record this. So they said, okay, can you help us with one of the students to help us to develop like a data mining tool, which can tell us when the aircraft needs maintenance based on the weather which is traveling to and the flight profile itself, how is the the aircraft performance. So we have all the data from the company, and then the student, he developed all of this data mining tool, and we focus only because only one student for 4 months. We focus only on one component, which is the thrust reversal in the engine, when you see the engine opening and closing during the landing and takeoff. So so we develop the data mining, and this is helping the company to know when they can do the maintenance for the structure of the aircraft. This again another project about smart manufacturing. So smart manufacturing here, when you talk about smart, you need data, you need digital, you become digital. So digital in this context, we are talking about the model. So the designers, they are designing this model, And then the manufacturing engineer taking this model and they convert it to 2D drawings to start the manufacturing. And then from 2D drawings, they start all the tolerances, dimensions, and so on for machining. And then Rolls-Royce said, okay, we should use the 3D model as like, a reference, as model-based definition. So we don't need to use 2D. So all the data set should be in the 3D. What I mean by all, so you have data for manufacturing, you have data for maintenance, you have data for even like, end of life as well. So, and the design. So all of this data set will be in the model itself. You don't need to convert again. So the shop floor should use this 3D model as the model-based definition in their manufacturing. Of course, this like, if you talk about component, it's fine. But if you talk about assembly, and the assembly is more complex, many components, many interaction, again, it's a big challenge for the organization. Then we said, okay, if you have this model-based definition for like a company like Rolls-Royce, is a big company, they can afford to do it, but you have suppliers. So will your suppliers ready to, or they have readiness to use this model-based definition? Because the suppliers will deliver the product and the components to you with all drawings, with everything. So they said, okay, can one of your students help us to have a framework to measure the model-based enterprise? Enterprise means like, Rolls-Royce plus their suppliers. So my students, Margot, she is a French student. Then she developed this readiness for suppliers, how to measure the supplier readiness for model-based definition based on their capabilities. Another, capability we have as well is about benchmarking. So again, Rolls-Royce, they said we are interested, about using additive layer manufacturing in aerospace. Additive layer manufacturing is well known in, or maybe now in medical and some small organization as well, or industries. But what about aerospace? So the students, they done like a benchmarking to look at additive layer manufacturing in different companies, and they produce a benchmarking report, which will be given to Rolls-Royce and the other companies as well. Sorry, I don't know if you can hear, so I have to take. Can you hear this music?
No, no sound.
Can you hear the music?
No.
Okay, so I have to take. Can you hear it now?
Yes, yes.
Can you hear it now? Can you hear?
Yes,
Can you hear
yes,
the
yes,
music
yes.
now? Okay,
Yes.
thank you. Sorry.
So just this is like a short video to show you about this project. So the idea of this project, it came from someone in Airbus. He lost his right arm. Then he said, Essam, can you help like us developing a cobot? Cobot is a small collaborative project, robot. Then I told them, okay, we can try to help in creating this one. But I said, can you have also a prototype as well? So to create a prototype, again, was a big challenge. But the student said, okay, we'll do it. So they took all of the requirements from Airbus and start developing, the cobot, model, all the communication with the cobot, and also how the cobot, like, help, someone, like, maybe lost his arm or something. So here, Maria can, maybe you can see this one now. There is no sound, but just demonstrating this cobot. So the cobot, you can see the small one and start, moving the arm, and it will respond to her arm as well. So you can see the cobot also responding to her arm. And it can be controlled from like something on the table or using the leg or the foot. So it's like like, I don't like to take much time in this, but this to show, what the students have done for Airbus. The second project here was about like, positioning of some components inside the wing of Airbus. So what the students did here is try to use a new technology, which is augmented reality, to position some component, which is a small component inside the wing. So I will show you these components. So the project here was based on requirement from Airbus. So you can see this small component. This is called the sticky bracket component. So this component, they have about 400 components inside the wing. But what they are doing to measure where is the position, so they are using like rulers and all of like, tools to measure where is this component inside the wing. So Airbus was asking about like, having this component using augmented reality to find the position inside the wing. Especially like the wing is not like an area for easy to work. And you can see it is like, sometimes dark area is not easy to work, and you can see the environment here. So, and also you need to, when you have the component and so on, you need to have like small holes to input, a man there, and the dark area to put these components. So the time consuming is not easy, job here. So the students try to use all of this like augmented reality capabilities to enable, the positioning of this sticky bracket inside the wing. And even the students, they produced like, they designed this small gun towards the sticky brackets, which using these tools can find the position and just shoot it to the exact position based on the CAD drones. Of course, this is giving a very good time reduction, nearly about, more than 75% in terms of time. So this is was huge time saving for the company rather than using manual way of put this sticky bracket inside the wing to automated way using the students model. So what are the digital transformation challenges? So there's a big challenge in digital transformation, really. One of this is about demonstration. So the companies would like to see like real life demonstration of how the digital transformation in the companies. For example, as I mentioned, the digital twin. So if we are successful to have digital twin for the whole life cycle, so from the design, manufacturing, and also operational and utilization services. Of course, this will give more like leadership in terms of using digital twin for life cycle. And when we look at the design as well, so design for normal manufacturing is different from design for additive manufacturing and digitalization. So the design again needs some work as well to have this capability for in the design stage. And of course, all of the data, sometimes different companies, they have different industry sectors, they have different needs as well. Just from technology point of view, of course, again, all of the technology in terms of data retention, data transfer, all of this is a big challenge with using the internet nowadays. It's huge now. In terms of business challenges, like when you have any transformation from traditional manufacturing to smart manufacturing, you have cost. So what would be the cost of implementation? How much will cost to move from traditional manufacturing to smart manufacturing in different areas? And then when you move to digital manufacturing, you need to have to understand the complexity. Because it not be traditional, it has to be like digital, so it has a lot of complexity as well, and you change business processes as well. So in terms of readiness, so what are the readiness level for the organization, and what is the roadmap? So how the organization is starting? So there is some studies now starting to look at this readiness level for the organization, and of course leadership is the key. So if we look at Kazakhstan, for example, here. So some companies should lead, this digitalization. So the other companies can learn from them and can start implementing this digital manufacturing. With that, I would like to thank you very much for your time to listening to this presentation. This is some of my students, working in companies, as I mentioned, and I'm so proud of my students. They are doing very well. And so grateful for companies to open their door for the students to have a good collaboration and to give real life deliverables to the companies. Thank you very much. And if you have any questions, I'm happy to take your question. Thank you. So we have a few minutes now. Any question? Any comments? Any questions?
Dear participants, feel free to ask the questions. Now, while you're thinking, I want to announce that we will have the open house day, 14th of November. I will send you here the link for the registration. We will have it won't be the usual open house day. It will be like in the format of a forum with young researchers, with startuppers. It would be really interesting. So feel free to ask the questions.
And also you have my email address. If you have anything, if you are interested in any of the areas or interested to join us in Mechanical Aerospace Engineering Department, you are very welcome, and you are welcome to contact me as well. So you have my email address at the bottom of the slide. All right. If no questions, we can close it now.
Okay.
Okay,
I
thank
just
you.
I
Thank you.
just would like to send this link. Please visit it.
Okay. Thank you.
Hello, can you hear me?
Yes, thank you very much. Thank you.
I'm a freshman of University. As for me, the presentation was quite difficult because I have not enough knowledge in this field. Could you recommend some books or articles to be engaged in this field?
In digital transformation.
Yeah, in this field, yeah.
Yes, I think, if you email me, I will send you some links for some publications. And again, digital transformation is a big area. So it is a big area, as you mentioned. And it really, you need to maybe take it in general in terms of digital transformation and or take it in a specific area. So digital transformation could be from enterprise systems, like enterprise, like the whole, how to manage the enterprise, like business processes, using an enterprise social planning system, or could be in a specific technical. So what I showed you today, mostly like technical, but also I have good expertise in enterprise social planning systems as well. So you can take digital transformation from business processes to implement like an ERP system, or you can take it from a technical, like model-based definition, digital twin, artificial intelligence, and other areas as well. So if you email me, I will send you some links. Okay, any other questions? All right. So thank you very much for your time, and look forward to see you at Nazarbayev University. Thank you.
Thank you, Professor. It was really interesting. Thank you, dear participants. See you at other webinars. See you at our open house day. Thank you very much.
Thank you. Bye-bye.